Hi, everyone. I appreciate the time you took to join us today. We're very excited to have you here. My name is Ami. I'm the VP of Innovations in Atlantic Technologies, and I'll be the moderator for today's session. Quick note on logistics here. We'll have a Q&A session at the end of the webinar, so if you have any questions, use the Q&A icon at the bottom of the screen to submit at any time as we go along during this webinar. Okay, before we dive into this topic, let me briefly introduce Atlantium Technologies. For over 20 years, we've been around being a pioneer in advanced water treatment with our proprietary HOD UV system. And we're tackling critical water quality challenges, including emerging contaminants such as PFAS, of course. So following our previous webinar a few months ago, where we presented inspired solution methods of destroying PFAS, we're excited to have this webinar moving from pilot stage into full-scale installation. This is a huge progress in providing a real solution to the PFAS challenge. Okay, now I'd like to introduce the Inspired Solutions. This women-led company is at the forefront of PFAS destruction innovation. And please welcome COO and co-founder Denise Kay and COO Sarah Meyer. So Denise, I think the floor is yours.
Thank you, Ami, and many thanks to Atlantium for your devotion to UV technologies and your continued support of Inspired's technology development. Hello, everyone, and thank you for joining us to learn more about on-site PFAS destruction, the user-friendly equipment that does the work, and how you can own this technology and add PFAS destruction to your service lines. During the webinar, we will cover details about the market opportunity for on-site PFAS destruction, an introduction to Inspired Solutions technology, which we refer to as photoactivated reductive defluorination, and the PFASigator, which is the equipment that implements this destruction reaction. We will cover some example use cases illustrating how the PFASigator works in real-world scenarios, and next will be a deployment and operation overview. Finally, some food for thought on owning and operating your own PFASigator that you can use to grow your business by offering on-site PFAS destruction to your customers. We will have time at the end for Q&A. So let's get started. So why now? It's a great question. The reason is there is an opportunity now to be an early mover in the growing market for PFAS remediation. Likely everyone on this call has already heard of PFAS, the forever chemicals. PFAS are extremely stable, synthetic, toxic chemicals that don't naturally break down in the environment. And since PFAS use began in the mid-20th century, they are now present throughout our global water supply. They just keep cycling around. Human exposure to PFAS comes through water, food, and many convenient household products. So convenient that many of us aren't even aware we're using PFAS and getting that exposure. Today, over 95% of us have measurable levels of PFAS in our bloodstream. And unfortunately, PFAS is now associated with negative reproductive outcomes and multiple types of cancer. So now I'm going to hand the presentation over to Sarah to talk about the regulations that are being implemented as a result of the toxicity and ubiquity of PFAS in the environment.
Thanks, Denise. And that's right. Because of the toxicity and ubiquity of PFAS in the environment, regulations are being developed and implemented to control exposure to the chemicals. These regulations, in turn, are driving a PFAS business opportunity. There is a big shift happening in PFAS regulations. State and local regulations for PFAS in drinking water, groundwater, surface water, and site cleanup, those are already in play and more are on the way. Deadlines for federal drinking water compliance are approaching, in addition to anticipated rulemaking regarding hazardous waste classification and effluent limitation guidelines, among others. Based on what we've seen in the marketplace, client demand for PFAS solutions can be urgent if they are being forced to comply with regulations and are at risk of fines or business interruption. Even if their need is not urgent today, the regulated community is already looking ahead to established compliance deadlines and what needs to be done to meet them. With new regulations and an emerging world of solutions, your clients may be looking for someone they can trust to provide a solution today or in the near future. Your clients are already looking for solutions. Are you ready to provide them? And you don't have to look far for industries that are impacted by PFAS and PFAS regulations. The impact is far-reaching and to varying degrees. From PFAS manufacturing itself in industries that used aqueous film-forming foams, or AFFF, to industries that have had PFAS in their supply chain at some point, either as a raw material or in components. It's hard to find an industry that hasn't been impacted by PFAS. Some of the industries with known histories of PFAS use and management are listed on the slide, and you may have existing clients with legacy PFAS impacts either at their facilities or in their neighboring communities because of historic releases. Traditional PFAS treatment methods essentially just move it from one location to another, capturing on a filter media, disposing it in ways that can re-release a portion back into the environment. This cycle of capture, disposal, re-release continues because the PFAS are not destroyed. Therefore, these are not viable long-term risk management strategies. And until recently, these treatments were all that were available. What we're talking about today, photoactivated reductive defluorination, or PRD, and the PFASigator, the equipment that applies it, breaks this cycle. It destroys PFAS in water, breaking them down into non-toxic discharge. Long-term risk is mitigated at costs comparable to or less than previously available options. So have any of your clients already been asking for a new way to manage their PFAS-contaminated waters? Maybe you've had calls from those clients about it, or maybe it came up over lunch as a concern. Based on our experience bringing a novel PFAS destruction technology to market, we know some of the questions that come up. Your clients may have some of the same questions, like, can you help me avoid regulatory penalties? Can you eliminate my PFAS, not just remove it? Can you do treatment on-site and avoid transportation risks? Can you help me control the cost of treatment? Can you help me reduce my long-term liability? And can you help me manage my PFAS and protect my business reputation? By adding the PFASigator to your fleet, your answer to all those questions can be yes. By owning and operating the PFASigator, you can destroy PFAS in waters on site and support your clients by reducing their exposure to future regulatory enforcement and providing peace of mind.
So PRD is an award-winning novel technology that destroys PFAS in water. We'd like to introduce you to how it works and how it is applied at commercial scale. PRD is applied by mobile, versatile on-site equipment called the PFASigator. Inspired Solutions manufactures and sells the PFASigator for you to own and use to destroy PFAS in waters. Inspired also provides the training and support for its use. The PFASigator is a batch reactor. Concentrated PFAS solution enters the reactor and liquid reagents are mixed in. The batch is circulated through the Atlantium UV light system, while fluoride is monitored as a real-time indicator of PFAS destruction. When the targeted level of destruction is obtained, the treated solution is discharged back to the waste treatment system. These panels are a simplified representation of how the chemical reaction works inside the PFASigator. In the first panel, the blue dots represent PFAS, just free in the bulk solution. When the PFAS contaminated water enters the system and liquid reagents are mixed in, they form a reactive cage, isolating the PFAS molecules. When the ultraviolet light is turned on, it triggers the reductive defluorination reaction, and the system is not pressurized and not heated, which keeps it much safer for operators. The result is harmless byproducts, including fluoride, water, and simple non-toxic compounds. This graph shows how PRD works in a real-world sample of surface water foamate. On the x-axis are PFAS compounds with EPA maximum contaminant limits, and the y-axis shows concentrations of these compounds on a log scale. The colored bars represent increasing UV dose during the chemical reaction treatment. So let's look just at PFOA to begin with. The initial concentration, represented by the orange bar, was about 10 ppm. When the UV light was turned on and the UV dose increases, you can see the concentration of the PFOA dropping by orders of magnitude until we stopped the reaction by turning off the light. The final concentration, represented by the teal bar, was less than 100 parts per trillion. You can see the same dose response curves for the other PFAS shown on the figure. So it's worth noting that the destruction is occurring on all PFAS in solution at the same time, including the PFAS precursors, and the destruction reaction continues until the UV lamps are turned off. If they are left on, the reaction would continue until all compounds reach non-detect. So key features of the PFASigator and PRD support the advantages of destroying PFAS in waters on site. These features include mobile equipment design to be owner-operated with low labor effort due to automation. The PFASigator is safe to operate because it's not heated or pressurized. The PRD reaction does not produce toxic byproducts, and on-site treatment mitigates the long-term liability that results from off-site disposal. In addition, your customers' long-term costs are protected from potentially dramatic changes in costs of transportation, disposal costs due to the economy, rising demand, and future regulatory restrictions. So PRD and the PFASigator have been tested in over 200 matrices from individual sites at both bench and field scale, and regularly achieves over 99% PFAS destruction. The chemistry is proven effective on long, short, and ultra-short chain PFAS. A single PFASigator has a daily treatment capacity of up to 1,000 gallons per day of PFAS concentrate. When paired with a pretreatment such as foam fractionation, which concentrates PFAS by 1,000 or 10,000 fold, this means that a PFASigator can effectively treat whole system flows of up to 1 million gallons per day or more. This is suitable for small or medium-sized industrial facilities, and for larger flows, the PFASigator is modular, and multiple units can be deployed in parallel for treatment.
But don't just take our word for it. As you ponder the potential for adding on-site PFAS destruction to your company's services, let's explore some use cases in which the PFASigator succeeds destroying PFAS in contaminated waters. These represent opportunities for the owner-operator of the PFASigator to use it in solving customer PFAS challenges. The PFASigator can be applied in multiple process flow configurations depending on the site needs. You'll see these represented in the use cases coming up. Several setups are shown here. Looking at option 1 in the upper left, this is a recirculating process flow where the PFASigator is connected to the tank on a fire truck in a process that simultaneously decons the tank and destroys PFAS for optimal cleaning. Option 2, upper right, is the same recirculating flow as option 1, but instead of a fire truck tank, the external tank is a storage tank of contaminated water that becomes the treatment batch for the PFASigator. This could be used for large volumes of containerized waters. Option 3, lower right, is for containerized waters that are treated in 50-gallon batches. This is the internal batch size of the PFASigator. This might be used for smaller volumes of containerized waters. And option 4, lower left, is a recirculating process flow where the PFASigator is combined with a concentration technology like foam fractionation for continuous flow situations like treating industrial wastewater, landfill leachate, or groundwater remediation. This application is likely a longer term or even permanent installation, and there are energy use and cost advantages to this process.
So let's look more closely at use case number 1, a fire truck changeover. PFAS-containing firefighting foams are being phased out. This means that fire trucks and fire systems that used PFAS foams will need to be cleaned out. In the standard process, thousands of gallons of contaminated rinse water are generated, and a vendor is paid to dispose of this contaminated rinse water. Inspired has developed a novel approach for fire truck and fire system decontamination that has been proven out through Department of War, and it opens a new business opportunity. This can be a new service offering, or if you are already in this market, you can provide a better process for the same cost as the standard process and keep more for your bottom line. Here's a photo of this process being implemented on a fire truck for the Department of War. The blue lines show how the PFASigator is connected in a recirculating loop directly with the foam tank and piping on the truck. The fire system is continuously flushed with warm water containing surfactant, while the PFAS is simultaneously destroyed every time the water circulates past the UV lamps in the PFASigator, where it is after the UV lamps, it's then sent back through the truck and continuously until the PFAS is released from the tank and piping and destroyed. So in addition to being cost competitive and schedule friendly, using the PFASigator has added benefits that will differentiate your proposal. This process has been demonstrated to remove and simultaneously destroy more than 20 times the PFAS removed by plain water rinse. The advantages to this approach include minimum fire truck downtime, simultaneous cleaning and destruction, and key is that there's no waste left on site. PFAS removal is maximized and rebound is minimized, and the process meets or exceeds existing guidelines.
Moving on to use case 2, containerized waters. We're going to look at 2 examples of treatment of containerized waters using the PFASigator. They use the process flows shown on the screen here, the recirculating flow with an external tank, and the batch flow using the PFASigator's internal batch size. The standard process here is to ship containers off-site for various disposal options performed by others. And the new opportunity is using the PFASigator in a recirculating flow or batch treatment process with a filter media polish to treat PFAS on-site. The new opportunity allows you to keep the revenue that would have gone to the disposal vendor. In our first example, we look at PFAS destruction in 4,000 gallons of containerized rinse water from cleanout of a sprinkler system. As Denise mentioned, AFFF is no longer manufactured and is being phased out in commercial applications. Fire suppression systems are being drained and transitioned to fluorine-free foams. The rinse water treated in this example is from a sprinkler system changeout at a chemical manufacturing facility. For this use case, the PFASigator was connected in a recirculation loop directly with each tote containing AFFF contaminated rinse water. PFAS was destroyed as the water continuously circulated from the tote to the PFASigator and back. Operations were conducted 24 hours a day using remote monitoring to confirm proper system operations. When the destruction objective was met, the solution that was circulating was then passed through a filter media polish and released to a local water treatment facility. Total treatment time for the 4,000 gallons was approximately 15 working days. In a second example of treatment of containerized waters, 600 gallons of foam concentrate were previously generated and containerized on site. Foam was generated by treatment of groundwater impacted with AFFF at a Department of War facility that previously used AFFF in firefighting and fire training. Initial total PFAS concentration in the foam was greater than 17 parts per million. The PFASigator automatically drew batches of contaminated water from the larger containers, 50 gallons at a time, continuously applied UV dose until destruction criteria were met, and then discharged the treated water through a filter media polish to meet EPA MCLs. Processing was run 24 hours a day for 8 days with automatic control and remote monitoring for reduced project duration and labor. Also of note here, there was no unplanned downtime during this demonstration, which highlights the ability of the equipment to treat consecutive batches reliably. The PFASigator has some unique advantages destroying PFAS in containerized water on site. Specifically, using the PFASigator allows for long-term cost control and risk reduction by not relying on over-the-road transport, long-term cost control and risk reduction by not relying on disposal by others. And bottom line, using the PFASigator for on-site PFAS destruction mitigates future liability. In addition to those two containerized water use cases I just presented, the stored fomate and the fire suppression system wastewater, there are other containerized water treatment opportunities, such as those listed here, like investigation-derived wastewaters, contaminated surface waters or storm waters, spill response waters, fire suppression response waters, and you can probably think of other applications based on the work that you do every day. Differentiating yourself with the PFASigator can help you win jobs by offering on-site PFAS destruction at a price that beats alternatives and delivers the additional benefits we've discussed.
So Sarah covered how PFASigator can be used for containerized waste, and I already talked a bit about using it with a fire apparatus decontamination. But you are the experts that talk to your customers and know their specific needs. I'm hoping these examples are starting to stimulate ideas, given the versatility of the equipment, that help you think about how you can satisfy your specific customer needs. But let's give one more example. Let's dig into a use case where the PFASigator is used to treat continuous flow waters in combination with pre-concentration technology. So the standard process with continuous flow, such as contaminated groundwater, is to load the PFAS onto filtration media or generate a concentrated PFAS wastewater and dispose of this off-site. Alternatively, as this diagram shows, PFASigator can be set up as a destruction side loop, which quickly establishes a steady state meeting effluent requirements with no off-site PFAS disposal. So here's an example of that flow setup to treat contaminated groundwater. This was a continuous treatment to control groundwater plume that was created by a legacy release at an industrial facility. This picture shows the installation of an on-terrace foam fractionation system with the PFASigator. You can see on the left the incoming groundwater pumped into these holding tanks, which contained 1,500 parts per trillion PFOS. And the discharge from these combined systems contained less than 4 ppt of PFOS with zero offsite waste disposal. So the groundwater was pumped into these, I guess the right word is break tanks. And then the water flowed from those to the foam fractionation device that you can see at the back of the room. And you can see the foam stacking up in the tower right over here. When that concentrated PFAS foam collapsed back to a liquid, it was routed to the PFASigator for destruction. It's worth noting that the volume of liquid going to the PFASigator for destruction was a small fraction of the total flow being continuously pumped from the ground. So following destruction, the PFASigator effluent was returned to the holding tanks to be combined with the incoming contaminated groundwater for the reconcentration of any remaining PFAS. In a second example of continuous flow waters paired with pre-concentration technology, PFAS was destroyed in landfill leachate foamate. Unlike the groundwater, which was clear and created that beautiful white foam, you can see in the beaker here a picture of what landfill leachate foamate looks like once the foamate is collapsed. Much less transparency, and the PFASigator was still effective in treatment. So the highlights of this demonstration include that the PFASigator was operating on site within 1 working day of the equipment arrival. There was active remote control and data monitoring the production of fluoride to watch the progression of the PFAS destruction, breaking those carbon-fluorine bonds. The field operation period was 4 weeks, with only 2 hours of downtime because a lamp replacement was required. And we achieved 95% destruction of the EPA MCL PFAS compounds before it was recirculated back to the foam fractionation system. So we've seen these advantages that your customers experience in earlier slides, and they are valid again in this case. So other potential applications of PFASigator in continuous flow scenarios include many things that you can imagine, such as plugging it into existing water treatment systems so that it is one part of a potentially much more extensive water treatment train. These could be industrial or manufacturing facilities, municipal wastewater treatment plants, industrial or municipal landfills, centralized waste disposal systems, pump and treat groundwater remediation, sediment dewatering operations, or treating reverse osmosis or nanofiltration brines.
One of the greatest advantages of the PFASigator is its ease of deployment, and that's by design. We specifically designed the equipment to not only optimize the destruction technology, but also meet the industry's desire for a skid-mounted, easy-to-operate unit. Today, it's one of the things our customers like best about the PFASigator. Our customers have benefited from how easy it is to deploy the PFASigator. Some of the attributes that make it easy to deploy are its small footprint. It's about a half day from delivery to completed installation. Denise talked about the automated operation on a 24/7 schedule with remote control and monitoring, which leads to the low labor required to operate it. We estimate about 1/10 of an FTE is required to operate it. It's operated with no added heat or pressure, which makes it usable without special safety training. And then because it is built from typical water treatment equipment, both the operation and maintenance can become quite routine, especially for those with water treatment experience. While you on this call, you're the experts in serving your customers and providing industrial services, environmental remediation, and systems integration, we know you will need some support to get to know the PFASigator and how it can be applied. That's why we offer the following support and training to our buyers, including startup support, operator training, on-site and off-site technical assistance, and maintenance plans.
So with the PFASigator in your lineup, you have a unique advantage in the marketplace. Remember, the PFASigator is yours to own and operate. This is a new paradigm for PFAS destruction. Environmental service providers can now deliver on-site PFAS destruction at a price comparable to existing capture and disposal options and the additional advantages we've discussed throughout this presentation. If buying a PFASigator isn't your preferred purchase option, but you're interested in adding the PFASigator to your services, we have lease options as part of our early adopter program, and we will work with you to find the option that suits you best. This new paradigm of owning and operating gives you more control and more revenue, while traditional options mean you buy someone else's treatment as a service with a service contract. The PFASigator is an in-house service. In traditional options, the vendor keeps control of the service and the performance. With the PFASigator, you control the cost, execution of the service, and make sure your customer is satisfied. In traditional options, you are likely to pay the vendor a risk premium, and with the PFASigator, you manage the risk yourself as you see fit. In traditional options, revenue is lost to the vendor. With the PFASigator, you keep the revenue.
By bringing the PFASigator to your jobs, you not only treat PFAS at a cost comparable to traditional options, but you also realize added value for yourself and for your customers. Some of those are presented on screen here for your consideration. For you, as a service provider, the PFASigator value centers around owning user-friendly equipment that provides a new, technically sound solution to a growing problem. Inspired Solutions has spent years testing and optimizing our PFAS destruction technology, and the PFASigator is your opportunity to own the award-winning tech and use it to grow your business. The value to your customers centers around reducing risk and uncertainty. As we've explored the marketplace, our discussions with those with PFAS challenges have brought to light their concerns about regulatory penalties, business interruption, and lingering liabilities. You know your customers best, and understanding their needs can help you decide if the PFASigator and its unique offerings can address those customer needs. We've talked about a new opportunity for PFAS management and the value it adds for both you and your customers. Why act now on this opportunity? Because demand is here today and growing. Regulations are continually evolving. Some of your customers are already facing compliance pressure, and some are anticipating future compliance deadlines and coming regulations. Be an early mover to win work with these customers now, and build your expertise and differentiate your service before competitors catch up. Grow your business now by adding on-site PFAS destruction.
We humbly welcome you to contact Inspired Solutions to discuss the technology and your vision for customer use scenarios. I'm sure there's many more that we haven't even thought of yet. You can visit a PFASigator in our Lansing, Michigan headquarters or at a field site. You can consider renting the PFASigator or for a test application or a field pilot. And we can always serve as operators until you are more comfortable and learn how and can operate it. Ultimately, you may consider becoming an owner or leasing the PFASigator through our early adopter program. So thank you for your time and attention today. Please reach out to Inspired at any time with ideas or questions. Our contact information is available at the QR code you can see on screen. And we'll use the remaining time to address questions you submit via the Q&A icon at the bottom of your screen be careful because the Q&A icon is different than the chat icon, and we'll be watching the Q&A.
Okay. Denise, I'm gonna open up the Q&A box here and get to some questions. First up from Mehmet Pelivan. Thanks for joining us, Mehmet. Can the system treat other contaminants like VOCs alongside PFAS? Denise?
We have done some work from contaminated groundwater at oil refineries, which had a significant amount of other contaminants, BTEX, benzene, toluene, ethylene, xylene. And we found that, yes, they were degraded, and we've also had success with 1,4-dioxane. So we have not done extensive research with these compounds and proven it out in a Department of Defense program like we have with the PFAS, but the real world on-site testing that has been done for customers has shown that, yes, it is quite effective.
Next question. Do you provide the reagent chemical or are they available to purchase in the market? I can take that one. Yes, we do provide the two chemicals that advance the destruction reaction. Those are delivered monthly or bi-monthly or on whatever schedule that suits how often you're using the PFASigator. There are also some commodity chemicals used to adjust pH and some other things on the machine. Those you can purchase in the marketplace.
It's worth noting that the machine is scaled and the refill requirements on the machine, if the PFASigator is running 24/7, you're going to need a refill about once a month. So not too frequent required interaction.
Okay, here's a question. Is for a continuous flow application, similar to decontaminated groundwater to use as a drinking water source supply. The question is, what precautionary measures to keep in mind if you plan to sue the potential polluter to recover the cost of PFAS treatment or destruction?
Coming from a background of environmental toxicology and litigation support, a couple things come to mind. I don't think it's the treatment process that will affect your ability to regain from the original polluter. I think the important thing is going to be measuring the concentrations of PFAS in that groundwater, and specifically of many of the individual compounds, because the ratio of those different compounds can be indicative of exactly the source of those. So you would want to be paying attention and getting that information from the groundwater prior to working with the PFASigator to destroy the PFAS.
That's a good point, Denise. I think this question also sort of highlights the fact that we are a technology developer and equipment vendor. And for something like this is pretty strategic planning specific to using groundwater as drinking water. A different kind of expert can probably advise you better than we can on how to plan for cost recovery from a polluter. There's a large ecosystem of people in the business of treating PFAS, I guess is the point. Okay, another question. Does the destruction technology need to be approved in advance? I'll start this one. It depends where you are. We've had customers and projects in different locations around the US. Each state has different permitting programs or even non-existent permitting programs at this point for this type of treatment. Local limits or permits may be in play here. So it's really going to be determined by the situation right at where the application is being implemented. And so reaching out to your local permitting agencies would be the first step there. Anything to add, Denise?
Yeah, I agree, Sarah. That's a it's different right now all over as regulations are rapidly developing and very dynamic in different locations. I think important thing we've noticed is, for example, when you're treating PFAS in wastewater coming from industry or from legacy contaminated groundwater, what we're seeing regulators concerned about is, are you achieving what is appropriate to discharge from that site, depending on the is it going to a wastewater treatment plant? What is that wastewater treatment plant willing to accept, given the systems they have in place at their site? So rather than the on-site regulators being focused on what treatment are you doing in those waste scenarios, they're more focused on, is the treatment effective at reaching what it is permitted to release from the site?
Mhm. Okay, moving on here. Are slides available? Yes. Atlantium will be distributing a link actually to the webinar following the presentation. Um, Ami, do you know if a PDF of the slides will also be available? I can't recall.
It wasn't in our previous webinars, but I think upon demand, it would be available.
Okay, thank
I
you.
think, I mean, we always welcome you to contact us and these slides, and we've given many other presentations that really dig a lot more into the science, the effectiveness on a whole profile of PFAS compounds. So we're happy to have those discussions with you and share slides information. On our website, there's case studies that have a lot of this data also. And through our Department of War program that we've done prove out of the technology, there are a lot of public documents available there also. Happy to share. Our goal is to be very transparent on what we're doing and the effectiveness of it.
How do you measure treatment progress in real time? I think Denise alluded to this several times in the presentation. Do you want to talk about the real-time fluoride monitoring, Denise?
Yeah, sure. So the thing that distinguishes PFAS compounds is the extensive number of carbon-fluorine bonds in the molecule. It's the strongest single bond that exists in nature, and that's why PFAS are so difficult to break down. So, sort of the golden apple in demonstrating that you are breaking these compounds down, just not breaking them into smaller fragments, but actually breaking the carbon-fluorine bond, is when the carbon fluorine bond is broken, the fluorine becomes the fluoride ion in solution. So the PFASigator has a system that is continuously measuring in the batch that it's treating the increasing concentration of fluoride. So that fluoride only increases as the carbon fluorine bonds get broken. And so that's demonstrating that the reaction is continuing and it is making the critical bond breakage to make PFAS destruction complete.
Yeah, I could also add there that this is something that if you would like to talk in more detail about that, we have data that we can share showing these curves of fluoride release from any number of examples and how we use that to predict the completion of a treatment batch and so on. So um, feel free to reach out directly to us for more information on that. And what are the smallest and larger capacities of PFASigator?
Ah, great question. Sarah,
Hmm.
I'm going to mention that to be respectful of people's time, I think we're coming to the end or have come to the end of the time of the
Thank
webinar.
you.
Let's address this question though. So we talked about, oh, we didn't talk about smallest or largest batch. So the batch size of the PFASigator, if you're doing it in batch mode, is 50 to 55 gallons. And then the duration or of the batch treatment or the ultraviolet light dose that it receives will be dependent on a number of things, including the complexity of the water matrix, the initial PFAS concentration, the target PFAS concentration, a host of things. The larger batch is accomplished, for example, if you have a tote and the PFASigator is hooked directly to the tote in a recirculation mode, then that batch is sized by whatever container holds the waters. So if you imagine that a tote is 250 gallons, you could do it batch by batch, 50 gallons at a time. It would be 5 batches. Or you could do it as one very large batch in recirculation mode. It would take 5 times as long as a single patch if you're pulling it batch by batch. I hope that helps.
Thanks, Denise. I guess that's a wrap, given the amount of time that was set aside for this. Thank you so much for your questions. Thanks for your attention today. You can reach out to Denise and I directly using the QR code on the screen. You can also find us on LinkedIn at Inspired Solutions. We look forward to hearing from you directly. Thanks again for your attention and have a great day.